Hi, thanks for clicking into this video. I hope to provide some help with graphing sinusoidal functions. And for this first short little video on this topic, I'm not going to dive into any specific Khan Academy problems that I've seen in there. I want to save that for a different video just to kind of keep these nice lengths instead of getting on and on like some of my other videos have been a little lengthy. So first off, before we closed schools, Wednesday and Thursday, before we closed schools, gosh, what was that? 13th or 14th? I think it was 12th and 13th. I'll double check. But we'll go back in the calendar here. We actually started talking about graphing sinusoids in A22 and A23. Oh, March 11th and 12th. And you guys know how to get to the notes through the Smartboard notes link up here. And I'm just going to pull those open real quick. And, it's been a while. And if you were, I think we had a blood drive one of those days, or if you were out for whatever reason, or it was just so long ago, you're having trouble remembering this, you're going to want to go back and look at these color notes and try to bring yourself up to speed. But I'll try to supply you with a little support here to help remember that. This first page we did a matching. So I had everybody get a graphing calculator out, and this would be good to kind of refresh yourself. One at a time, graph these different sine functions and try to figure out, and you can see we matched. People came up to the board. You might remember this. I had one volunteer per match try to do that, and I think we got this done in 4 minutes or less. And that's a good place to start. Notice we are in radians. If you're on your TI 84, make sure you're in radians if you're going to set your window to these dimensions I have here. So that was kind of our opening activity. Let's go to the next page. The reason this was so important is I started with sine, but quickly brought in cosine. And as you go to this page right here, where we have all the different layers and kind of color-coded. The parentheses here are a big deal when you're looking at phase shift, which is your horizontal left and right shift. Typically, people start out talking about amplitude and vertical stretching or shrinking, depending on if A is larger than 1 or less than 1. But we handle that sine separately. That's a vertical reflection if it is negative. And so we kind of talked through these layers, more or less. Made a big deal about the parentheses around x minus c. I mean, sometimes you run into theta for a variable, but you can see our control variable is x here. And then the b value is not period, but it does help us find period. So if you're dealing with a sinusoidal graph, either sine or cosine, period is calculated by 2 pi over b. Or if you're given the period or a graph to look at and you can find the period, you can build the function and find b by going 2 pi divided by that period that you found. Again, period is the length of one full cycle of that sinusoidal graph. So read through this or get your own notes out if you took some good color notes back on that Wednesday, Thursday. Or refer to this page here. It does go a little bit further. And phase shift is just to describe left and right horizontal shifts for periodic functions. All right, so the b has to be factored out of that interior expression, and it's always easier to find phase shift if that's done already. But if it's not, as I've noticed in a lot of the Khan Academy problems, you need to factor that common value out. And I'll get to some examples of that probably in another video. Okay, let's go to the next page here. Okay, we are establishing the anchor points, the suitable anchor points, tracking sine and cosine. They have very patterns. Sine starts at the origin, tops out, quarter period later, halfway through the cycle, it's back to the midline, 3/4 period, you're down at the bottom, and one full cycle completes at the same point, behaviorally speaking, back at the midline, headed up. Okay, so those 5 anchor points, which are quadrantal angles from the unit circle, are what we use to track sine curve. cosine patterns at the top of the amplitude instead of at the midline. So if you can remember those points and patterns, just shift it over slightly, and you've got cosine starting at the top, then midline, bottoming out, midline, and back to top. That is a period of 2 pi, and that's what the anchor, or that's what the parent functions start out with before they get transformed. Okay, next page. And again, just doing a refresher on some notes we had before closure. And a lot of you did A22 and 23 and got it checked off before we left. Some of you, like I said, were gone, and I didn't get this from you yet, so that may not be in Power School, but I bet most, if not all, have started this. So some good problems to go back and look at. Let me get to one other page here. This and kind of start to get us into those sinusoidal graphs and questions you'll see in Khan Academy. So we've actually got 3 different things going on with this sine function. You've got a negative out front with that coefficient value, which is going to be our amplitude of 3/2 or 1.5. The negative is going to supply us with a vertical reflection. So all your y values for each of those anchor points that we know are going to be negated. So your maxes will become mins, mins will become maxes, and all your x-intercepts will be kind of those hinge points where everything kind of reflects around. And then the b value of 2, remember period equals 2 pi divided by b when we're talking about sine and cosine. You'll put that into that little formula there, and 2 pi divided by the b value of 2 will reduce to pi. So our period length, one full cycle, is going to happen in a total of pi radians. So you can go through the midline, down, bottom out, midline, top out, and then back to midline, headed down in pi radians. And in the notes here, I kind of went crazy and supplied anchor points in both directions for quite a distance. But most of the time, I think this one says, okay, well, this one said on a window of -3 pi to +3 pi. So I think that's why we did it. But most of the time, I would say most worksheets and test questions in my course, one full period labeled and scaled, those 5 anchor points accurately labeled and scaled is enough. So that would be from here all the way to here, those 5 blue dots. Okay, one more page, I think. Click through here. Okay, and so on page, let's say it's page 6 or 7, no, page 8 of this notes document, you will see us start to deal with phase shift and pulling that b value out. And one way you could do that quickly is if you can recognize the b value is just the coefficient on that variable on the inside layer, take the reciprocal of that and multiply it times that other constant, and that'll give you the so-called C or phase shift value from that inner layer. So reciprocal of b times that constant, simplify that, and you'll get the, in this case, phase shift to the right. Okay, so x minus a value is going to be phase shift to the right by pi quarters. All right, so there's some key pages in these notes, and I would look back and try to refresh on that for kind of our flavor of how we introduce this stuff. And then hopefully in the next few hours, I can get another video up with the Khan Academy specific questions. And look for that on my YouTube channel in the next few hours. All right. Thank you for your diligence, and keep up the good work.